Hi guys, I hope you are all having a good day. Today we are going to do a chemistry experiment wherein we are going to convert an alcohol to the corresponding alkyl halide via an SN1 reaction. For this experiment, we will be using tertiary butyl alcohol. We call it T-butyl alcohol for short. And we are going to use HCl as the source of the halide, and we are going to convert the T-butyl alcohol to the T-butyl chloride. And this reaction will be proceeding via an SN1 reaction mechanism. SN1, the S stands for substitution, the N stands for nucleophilic, and the 1 stands for unimolecular. Now, typically, when we convert an alcohol to the corresponding alkyl halide, if we are using a primary alcohol, that reaction will proceed via SN2 mechanism. Again, the S stands for the substitution, N for the nucleophilic, and the 2 for bimolecular. Now, if we are using a secondary alcohol, that reaction can proceed via SN1 or SN2. In this case, however, we are using a tertiary alcohol, as you can see there, and the tertiary alcohols typically convert to the corresponding alkyl halide via SN1 mechanism. Now, what exactly is the mechanism of this reaction? So we have the T-butyl alcohol here, and we are reacting it with HCl. Now the HCl is acidic, and the alcohol will react with the proton of the HCl, and it forms this molecule. Now this positively charged ion releases the H2O. We lose a water molecule, and then we form this carbocation species. Now remember that we started with HCl, so when the lone pair of the oxygen attacks the proton of the HCl, we form the corresponding chloride anion. So we have the chloride anion available in the system, and this chloride anion will then attack the carbocation and leads to the formation of the corresponding alkyl chloride. And this reaction is pretty straightforward, but we are dealing with HCl, and we need to be careful when handling HCl. HCl is highly corrosive and it is dangerous, so we shouldn't be breathing it. And the thing to note is the T-butyl alcohol, our starting material for the reaction, it tends to be a solid at room temperature. So before we start the reaction, we actually need to put the T-butyl alcohol in a warm water bath so that it will become a liquid for us to handle it, because we are going to measure 15 milliliters of T-butyl alcohol, and we are going to need 44 ml of HCl, and we will be converting this to the corresponding alkyl chloride. So let's get started.
So the reagent that we're using today are tertiary butanol. Tertiary butanol is solid at room temperature, and we're keeping it on a water bath to convert it to a liquid. So it's a liquid right now. You're also going to use hydrochloric acid, which is very concentrated. And also we have to cool it down in an ice bath. So we are going to measure our required amount of hydrochloric acid, which is 44 milliliters, and put it on an ice bath. We need 15 ml of tertiary butanol, so I'm measuring that on a graduated cylinder.
Don't forget to cap your reagents once you are done with it.
Now I'm going to take the reagents into my bench hood. Remember that hydrochloric acid is corrosive and it's very volatile, so it gives out fumes of the corrosive acid. So when you're doing the experiment, make sure you're wearing gloves and you're doing it in a bench hood. I've cooled down my hydrochloric acid in an ice bath, and now I'm going to pour the cold hydrochloric acid, all of it, into the separatory funnel. Make sure that your stopcock of the funnel is closed. Pour hydrochloric acid slowly with the help of a funnel to ensure that you do not spill it anywhere. If you do, clean them. And then I'm going to pour my tertiary butanol slowly. As you can see, there are two layers now. One of them is clear and the other one is cloudy. What we're going to do here is, for the next 20 minutes or so, we are going to keep the lid open and we are going to swirl the solution every now and then keep it back here. Let it settle. Every 5 minutes, you're going to take the stopper and close the sep funnel. Hold it here so you ensure that the stopper is closed properly. You're going to invert it, swirl, turn the stopcock on to allow gas to escape, and then close it, put it back on the ring stand, and take the stopper off. Now that the 20-minute is up, I want to show you that there are two distinct layers now. One of them is slightly clearer than the other layer. The top layer is clear and the bottom layer is slightly hazy. What we're going to do now is to test which layer is our aqueous layer and which layer is the organic. So I have deionized water in an Erlenmeyer, and I'll collect the DI water with the help of a pipette. And I'll put the separatory funnel back on the ring stand, let it settle down, and then add a drop of water to see which layer this drop goes into. The water goes into the bottom layer, so the bottom layer is aqueous layer. Now that we know which layer is our aqueous layer, we are going to collect the aqueous layer in an Erlenmeyer. We're going to wash the organic layer with about 10 to 15 ml of DI water. aqueous layer again. And then we are going to wash the organic layer with 5% sodium bicarb solution. So sodium bicarbonate is a base and you have hydrochloric acid in the media. So there are chances that if there is any remaining hydrochloric acid left, there will be bubbles of carbon dioxide that's going to produce. So if you close your stopper onto the separatory funnel, make sure you vent it very often to let the carbon dioxide escape. Once all of the carbon dioxide has escaped, we're going to put the sep funnel back onto the ring stand, allow it to settle down. We'll remove the aqueous layer and then wash our organic layer one more time with water. Once we have removed the aqueous layer, we're going to collect our organic layer in another Erlenmeyer. And there might be some residual water left in our organic layer, so we're going to dry it with the help of calcium chloride pellets. What we're going to do is we're going to put some pellets, enough pellets to cover the bottom of the flask, and then swirl the flask and leave it for 10 minutes.
A few minutes later.
Once your product is dry, you're going to use a funnel to transfer your organic layer into a round bottom flask in which you will carry out your distillation. assembled all our setup for the distillation according to the instructions on our manual. What we're doing is on one stand we're putting in 2 wooden blocks, and on top of that we're putting in a thermal well on which we're putting our round bottom flask which has our organic product in it. We're using a 3-way adapter to close the round bottom flask. Make sure it's well greased. On the top we are putting in our thermometer with the red fitment to put our thermometer in, and the outlet in the middle we're connecting it to our condenser, putting a clamp, a kick clamp on both sides. We have our receiver end, and for the first 10 drops from the receiver we are going to collect it in a beaker. The condenser, the bottom part, is connected to the tap that will collect the cold water in, and the hot water will come out from the top into the sink. So we'll turn the water on. We are also going to heat the round bottom. We're using this control to heat our thermal well here, so that when you're heating it and it reaches the boiling point of your organic product, which is your tertiary butyl chloride, it's going to start evaporating, and the gas will move up here and go through the condenser, and the first 10 drops will be collected into the beaker. Make sure you note down when you start to see the first few drops. Make sure you note down the temperature when it starts to boil.
A few minutes later.
It's starting to boil. Before we set the heating up, we put 2 to 3 boiling chips on it, and now it has started to boil at around 26 degrees Celsius. Once so the condenser is set up in a slanted way so that when the liquid converts into a vapor, the gas will go and flow all the way to the condenser and be collected on the receiver end. Just to make sure, we are collecting the first 10 drops. It's already starting to fall. We're going to collect the first 10 drops into the beaker, and then we are going to collect the rest of it in our vial. So droplets are coming out now. Also, just be careful to see if your liquid here is all collected or gone. Keep on monitoring it and make sure you look at the temperature. The temperature is still increasing now, so you can, if you want, reduce the heating portion of the thermal well a little bit if it heats too much. The temperature right now is at around 51, so I reduced the heating a little bit. And also when you're monitoring the liquid being collected, don't let it go to dryness. As you can see, it's almost empty now, so we are going to stop the heating and we will remove the round bottle from the thermal well. We have disconnected everything from the heating mantle, and once there are no more droplets being collected, we will remove the receiving end from there. And we will take the IR and the mass of the final product. The droplets have been collected and there are no more drops that are coming off, so we will weigh the product now. Once we have our product, we are going to weigh to calculate our actual yield of the product. So we're going to use the analytical balance. So the weight is a stable weight at 21.039 grams. We're going to note it down and then find out our actual yield. Whenever you're taking an IR, you need to do a background first. The background contains carbon dioxide and moisture, both of which are IR active, so they might show up. So when you're doing the IR, select background and then scan it. Once your background is done, you can scan your samples in. So we are going to do both the starting material, which was tertiary butanol, and we are going to do take the IR of our product. So I'll do the starting material first. I'll put it on the sample thing. So the compound is a liquid, so you don't have to use a pressure gauge for this, and then we'll scan. And then press scan again to get proper IR. So the spectrum is complete. We select on label and we get all our peaks here. So make sure you note down the necessary peaks. Your starting material is an alcohol. Try to think of what functional groups show up in the alcohol region. So our alcohol peak is usually around or above 3000 and are generally broad. So this is what you're seeing here, around 3359 per centimeter. You will see a peak around 3000, which is 2971 to be exact. It's an intense peak, and the peak is for CH stretches. Anything from 450 to 1400 or 1500 is generally your fingerprint region, and they are unique for each type of compound. So once you have noted down your IR spectra for tertiary butanol, we're going to clean our instrument and then we're going to do the spectrum for our product. To clean, we wipe the sample portion with isopropanol, let it dry, and then we are going to put our sample for the next one. The sample portion is dry, so we're going to put our product. Make sure you run the IR quickly because this product is very volatile and you don't have to do a background the second time. our spectrum is done, and now we are going to label them. If you can see now, try to note down what the differences are between the two peaks. This is the product IR peak, and we have a peak at 2981 and another peak at 2928, and everything else is in the fingerprint region. So this is our product. So in the product, you don't have the broad peak around 3300, which tells you that all of your alcohol OH has converted into the chloride. Also try to note down the carbon chlorine stretch. It's usually around between 700 to 1200 ish. So this is probably 809.78, which is the carbon chlorine stretch.